calculate the sum of squares for the set of scores shown below. And our scores are 3, 3, 6, and 2. Now, we don't know if this is a sample or population, but when it comes to the sum of squares, it doesn't really matter. My definitional formula looks like this if it's a population. It looks like this if it's a sample. It doesn't really make any difference. I'm just subtracting the mean from each one of my x values, squaring them, adding them up. That's my definitional formula. If I was doing the computational formula, it's the sum of x squared minus the sum of x in brackets squared, either over big N for population, or sum of x squared minus the sum of x in brackets squared over small n for the sample. But again, the formula doesn't change, just the way that the symbols look changes. So the math is going to be the same no matter which one I do. So here I'm just going to pick an arbitrary one. This is the one I prefer to use. So I'm going to go with finding the sum of x for this part up here. And let's start off there. So 3 plus 3 is 6. Another 6 makes it 12, and then I'm up to 14. I know that n is equals to 4, but I need to know what my sum of x squared is. So I'm going to square each one of these values, 9, 9, 36, and 4. Add these up. So 9 plus 9 is 18. 18 plus 36 gives me 54. Plus 4 is 58. So my sum of x squared is 58. So now I can find my sum of squares. It is the sum of x squared. So that's 58. Actually, let me write out the formula just to make sure that you can see exactly what it is I'm doing here. So this is 58 minus the sum of x in brackets squared. So that's 14 squared over 4. And 14 squared is 196. Divide that by 4 is 49. So this is 58 minus 49. This is equals to 9. So the sum of squares is equals to 9. So my answer is C.